Hello, everyone. My name is Menzi Xulu. I'm a senior process engineer at Multotec Process Equipment, MPE. My presentation today will cover 5 things that you need to know about copper processing that will impress your boss. Here's the content of my presentation. It will cover a brief explanation about spirals, the benefits, and then we'll also touch on R&D facility and test work programs offered. Also discuss previous test work, and I'll also introduce to you to our 20-ton per hour modular test unit that we use for copper fines processing. Okay, on this slide, basically what I'm trying to say here is that spirals are used where there is a difference in specific gravity between the mineral of choice as well as unwanted gain. So then in that case, you can be able to utilize spirals. And at Multotec, we have a wide range of spirals that will suit your application. And for copper processing in particular, we have the SC20 and the SC21 spirals. The SC20, we use it in the rougher and scavenger application, and the SC21, we use it in the cleaning operation. In some cases, we also use the HX5, which is a large diameter spirals, and depending on feed grade as well as the PSD of the material, we might as well select that spiral. All of these spirals are available either as twin or triple stars for increased throughput. Okay, here, let me first discuss, we're going to discuss the benefits of using spirals for copper processing. So number one, we use spirals mainly for bulk rejection. So usually the natural and crushed fines, they contain about 20 to 25% of fines as percentage of run-of-mine. And from previous test work, we have seen that we can reject up to 80% of mass of gangue-containing minerals to tailings. This has got a benefit of reducing the size of expensive equipment, such as your leach tanks, flotation cells, and so forth. And it's most important for brownfield projects where the cost benefit can be incorporated into the design model in order to achieve good return on investment. So here the benefit is reduced capex. That is very key. Number two, spirals can be used for pre-concentration of copper to sellable products. Usually in this case, we use a 4-stage circuit that consists of rougher, cleaning, as well as scavenging. And we have in the past managed to upgrade malachite in Zambia from 3% copper in the feed to about 20% in the final concentrate by utilizing spirals. The benefit of pre-concentration is that it reduces the cost of reagents and downstream processes. And we at Multotec, we have installations in Zambia, Zimbabwe, and the DRC, where we have seen that the product upgrades can vary between 15 to 20% copper in the final concentrate at about 20% mass yield. So usually, this is most applicable for small-scale operations where initial revenue is of importance, and that the copper concentrate can be sold to bigger operations for initial revenue. The benefit here of pre-concentration is to reduce OPEX, like I've already mentioned, on reagents, and it can generate initial revenue on the fine circuit. So now, what we have an R&D facility at Multotec where we offer full-scale pilot testing on different types of spirals that are applicable for copper processing. And we run with the client in terms of defining the scope in order to suit your process requirements. And then from there, the test work results are used to confirm the selection because we might have to do comparison test work on which type of spiral is suitable for your application. And we also use the data to set up mass balance of the circuit and to issue process guarantees. Here in this slide, I'm showing you a typical pre-concentration flow sheet for copper beneficiation. So ideally, this is an upstream process that involves crushing, screening, scrubbing, and as well as a DMS circuit, and lastly, a spiral circuit. What I want to mention here in the main, and which I will also mention at a later stage, is that the top size on the jaw crusher as well as the cone crush is important for liberation purposes. That is why it is important to understand the mineralogy of the sample or of the ore you are treating, because that's got an impact on downstream processing, such as the spirals. In this case, the -1 millimeter fraction that you see right here at the end from a double deck sizing screen. Here, usually it contains about the 20% 20% mass from a run of mine, which is then fed into the gravity circuit. Typical examples where we have run test work on samples, we have shown that we can actually produce a sellable product containing 20% copper from a feed containing only 2.4% copper. And here I'm showing you a grade recovery profile, which shows an inverse relation between recovery and grade as expected, where it is clear that if you want to achieve a 20% product grade in the final concentrate, you will have to give up a certain portion of recovery. So in this case, we were able to produce a sellable product of 28% copper, and this was achieved at a 48% copper recovery. And the copper grade in the tailings was less than 0.85%. On this example, we have a 3-stage circuit, and where the aim of the test work was to ascertain the upgradability of the ore to spirals processing. And we are utilizing SC20 LG spirals. And we're able to show that on this circuit, we can produce a product with 11.5% copper at a mass yield of 10%. However, there's a few things that I need to mention here. Unlike in the previous circuit where we're using a 4-stage circuit and we're able to get a 20% copper in the final product, in this case, we were only able to get about 11.5 at a mass yield of slightly less than 10%. So we're upgrading from 2.4 to about 11.5%, and we were able to reject 10% of the mass. Now, the big question here is, how likely is it to move from 11% to about 15 or even 20% when we now have only 10% of the mass? The answer is very simple, highly unlikely. And whether is that a viable option now to produce a sellable product from here? And the question lies again in the mineralogical analysis of the sample, because from this ore, it is clear that this ore is hematitic in nature. It contains a lot of iron-containing minerals. So in this case, it is not easy now to upgrade the copper beyond 11.5% without removing the Fe, which then requires the Fe to be removed magnetically. So in this particular case, perhaps it is better now to use this scenario as a bulk rejection, because we have seen that now we can reject about 90% while upgrading the ore from 2.4 to about 11.5% of the mass. So it is important again that when you're dealing with the fines, you also do a mineralogical analysis of the ore. In this case, you can do even a qualitative analysis involving XRD. Okay, number 4, we have a 20 ton per hour modular test unit that we utilize for testing on site. So this test unit can be configured into a maximum of 4 stages of processing and will produce a concentrate and a tailings product. It's a simple unit which is fitted with interchangeable spirals, and piping can be rerouted to suit your plant or process requirements. It's very easy to move it around. It can be loaded into a container or a 12-bed on a 12 flatbed truck, and can be moved from one side to the other for testing purposes. However, for small scale miners or for low scale operations, this unit can also be used in producing a final concentrate that can be sold to bigger markets. So that's the advantage of it. So there is a guaranteed return on investment on this unit, and the estimated return on investment can be obtained within a year and within a 1 year period of operation. So like I've said before, it is a unit that can be used to generate initial revenue, and it's very simple to use. And it can also be utilized in pairs, and thus can handle more throughput for large applications. As I've shown you in this picture, we have 2 pilot plants or modular plants working in pairs. Each unit has a capacity of 20 tons. So in this picture, we have a modular unit that can handle a throughput of 40 tons per hour. And therefore, we are able to even generate more revenue by utilizing this unit in pairs. So this is a total solution of your copper fines that requires very little maintenance, and yet we are able to achieve results. Thank you very much. So that's it.